don't know, some of you might have seen this talk before. I know we've definitely had Clojure and ClojureScript at Fuza over the years, and it's ironic, when I saw those talks, I didn't get it at all, and look what I'm doing now. So, but anyway, who here has built a single page app? No matter the size or scope, or can you wants to build a single page app? Wow, okay. Rails views is way simpler. So this is who I am. I'm a startup-y guy, always like being there in the trenches in the early days of companies. I'm Kenneth Kalmer everywhere online, and always have the same avatar and everything, so I'm quite easy to find. And this is kind of relevant because, like, Aslam pointed out, like, how many of us have been building software professionally for how long? But I've been building just websites, like toying from high school, for 20 years. I've seen quite a lot. Some of it pleasant, some of it not so pleasant. Some of those where, like, just as you consider starting to use it, it's gone. The classic JavaScript fatigue. And it's interesting to see how many of these are still around. And, like, I would actually point at Ember specifically. It's like a magical piece of code. If I had to start from scratch and I can't use my current toolbox, like, Ember is a fantastic tool to use. But all the other tools have gone through so much pain and big changes, or are just gone, or got obsoleted by the platform. And it took a lot of time for us. There was a lot of lessons that needed to be learned and relearned over time. So if you think about the future of a single page app, it's like immutable data structures is a big thing. You see that with React and Redux. You get it with immutable JS. Functional programming ideas are starting to come back in a big way. And it's for a lot of reasons. It's not like there's anything like very specifically wrong with OO, but in a world with much more memory, you can actually do interesting stuff with immutable values because you can hold on to the before and after. You think where these guys came from when they had to develop the OO principles, we were talking about dollars per megabyte of RAM, not gigabytes per dollars. It's a whole different mindset. Same with relational databases and normalization. It was optimizing for expensive storage, nothing else. So now that some of these ideas we saw the NoSQL movement, it's like storage is free, essentially. So let's just drop all these old constraints. Memory is now becoming affordable too, so now you can latch on to new ideas, which makes things a lot simpler. And immutable JS is like a funny one that won in a certain way, but if you go look on GitHub, just search for immutable JS kind of libraries, there's 50 different libraries. When I made this presentation the first time, that might have quadrupled by now, as these things tend to go. But we need to reframe that whole thing a little bit more. Having immutable state, it's more to remedy against the effects of time on your system. It's something we're not particularly good at as developers. We're never trained to think of things happening over time. It's almost always you look at this one atomic set of code and it just starts and ends like at exactly the same time, and that's how you reason about the world. If you start doing threading, you start going into a world of pain because now for the first time you're challenged with time. It might not run the same way you think it would. It's a very, very interesting problem to solve. So, and then part of it's also like if things can't change, you've got less points at which you need to orchestrate that do that coordination, which is heavy and expensive. Another databases is a good example of where people are constantly fighting to reduce the number of locks in the system so that things can just go fast. Locks are expensive. But we also like, but you think of time, you also want to ship the smallest possible payload to people. Because it's like time is precious, like somebody's waiting for something to happen. You see like Mike with the progressive web apps, that's all like that. The whole thing is just about, can the user interact with our system in the least amount possible? Like that is a thing we're gunning for. And it's just time. That's what we want. We want a way to inoculate ourselves against the effect of time. And that's kind of like what this talks about, some tooling and a language and stuff that helps you to think through things in this way. So I'm going to be talking about a framework, not a library, called Reframe. It's a pattern for writing single-page applications in ClojureScript with React underneath. So it's wrappers, over wrappers, over wrappers, and eventually React's the bottom of the stack. So I use React, but I've never actually written JSX or any of that. I look at that code and my eyes start bleeding. But because it's a functional framework, it's actually all about data and the pipelines that transform the data as it moves up and down the interface and what people do with it. And yeah, so like I mentioned, it's written in ClojureScript. So what is ClojureScript? It is a version of Clojure that compiles to JavaScript. It brings the best of Clojure to JavaScript, including the rich immutable data structures that Clojure has, which is quite a dream to work with. And it's interesting, it doesn't compile to just any JavaScript. It compiles to the most boring ES5 JavaScript that you've ever seen in your life. And that's important because the Google Clojure compiler is responsible for doing the optimizations at the end. And it's actually amazing what that tool can do with your JavaScript. It can even, like it does, the nodes now, NPM's been running for the dead code elimination or tree shaking quite a while now, and it's been like everyone's been fighting for it. The Google Clojure compiler had it in since the very early days. It's an absolutely amazing library. It's like no matter what tools the Google engineers use on all the different properties, it runs through the Google Clojure compiler in the end. Absolutely amazing tool. But ClojureScript can also target Node, so you can make nice little CLI apps or little utilities that's nice and snappy and fast. And there's a few tools already like Lumo and Plank, which is essentially Node with ClojureScript completely built in, ready to go, and you can use it for little scripting tasks. So, and then Clojure, underneath all of this, is a functional programming language. Its strong point is definitely the persistent, immutable data structures, which 10 years ago, I guess when it started, it was an expensive operation to do. But these days, machines are so powerful, it's actually exactly what you want. And a persistent, immutable data structure is something, if I've got an array, and I put something on the end, I get a whole new array back. But the first three elements, let's all the original elements in the original array, like it's just linked in memory to their places in the new one, so there's not a duplication, and the new one gets added. So there's like a little cost, like hopefully the links is cheaper to run than your actual data that you're putting in there. But it's a different way of thinking about what happens in your system. It's a great thing to do, which also means you can keep track of the past, and you can always go back to the past. Like we got here and this was a fail, like no, let's just take 2 steps back, take a different path and see where we end up. Clojure is also very big on data first. Try and express things in data, not in code. Because the more you can do that, the easier it starts to be reasoning about the world, and it's easier to debug. It's fantastic, and it's to the point where Clojure is written in its own data format, which is quite bizarre. And you'll see some of the code. Daniel broke the ice when he showed all the S expressions. If you like just squint ever so slightly, you're looking at a Lisp, and that's where that came from. Clojure is also interesting because it's designed to be a hosted language. So Clojure by itself officially targets the JVM and JavaScript runtimes. But people have built other implementations that run on .NET, on Erlang. There's been a few other like little experiments. It embraces the host language. It allows you to do any kind of interrupt you need very easily at the point where you need it. It's super pragmatic. Unlike a lot of other languages, especially if you think like the compiled to JavaScript world, there's so many languages that try to completely hide the fact from you that you are in fact actually in a browser. And you've got to use these weird ideas of the authors, like their view of the world. And they don't offer you the escape hatches. I forgot the language now. Elm. If you use Elm in the front end, if you want to interact with any one of the million NPM libraries that got launched before lunch, you need to write ports. Like they're trying to push the JavaScript world as far out to the edges as possible. And I understand that reasoning. But when you can pull the stuff into your systems, on the JVM side, you've got access to millions of man-hours worth of libraries. And you don't need to write any Java to interact with it. It's fantastic. And the same on the front end for ClojureScript. It's also designed for concurrency, and that comes from that persistent immutable data structures. So now when things can't change, you can very easily start doing stuff in parallel. But people always like making fun of, of Lisps. So the gist of the story is that a Russian spy got the last page of some CIA documentation or code, and they were super happy that they found this. But I like this one more. So this year will be 60 years that Lisp has been around. I mean, that's quite a long time for a language to be out there and survive. I love this quote that people say, it's often emulated and pillaged, but still not duplicated. And any sufficiently large enough system will eventually grow to have some half-baked system of Lisp in there in any case. It has almost no syntax, which is bizarre. Like Ruby is the same in that way, actually. It's very, very little syntax. And it makes it a pleasure to work with. But one of the core advantages is still the code as data and data as code idea. Like it's fully homo-iconic is the term that these things flow. And another interesting tidbit is that John McCarthy, the creator of Lisp, he was responsible for giving us the if statement, or popularizing the if statement. Before he did that, people wrote, they had their punch card algorithms that they would feed into the machines, but a human would look at the information coming in and decide, oh, it's better to go with this program. So we were walking if statements. And he was the one that could help us pin it down in a way that a machine could understand to start helping the semantics of it. So that's interesting. And given we also had some talks on AI, Lisp came out of AI research and development. So I've got no idea what they did with it, but they did some amazing stuff with it apparently for the time. But let's get a little bit back on track. So Reframe is a functional programming framework around reagent, and then reagent wraps React and React Native. It's a very, 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 very small wrappers because React is actually so functional, makes it a hell of easy to just give it a different syntax and make it more usable. Reframe uses a data-first approach. It's the most important thing in your system is your state. It's probably also, in any system, the most important thing, but we never treat it like that. We worry about the stuff like things off by 1 pixel and stuff that doesn't matter. It's impressively buzzword compliant. I'm not going to go through the list, but it's functional, reactive, it's this, that, the next. It's been around since 2014, and it kind of works like a water cycle. It's just this never-ending perpetual loop. Are there any changes in the world? Apply the changes. Are there any actions to be taken? Do the actions and just sit and wait and just run. And it's elegantly simple model to sit and work with when you try and figure out what's actually wrong with your system, because you can just trace this path and see what's going on. So all your state is stored in one place. There was a time when we frowned upon this. You're like, no, we can't. We need to move all the values and hide them into other distinct little places. You got some weird stuff where, like with Angular, you had the dollar scope, and everybody just smacked everything on the scope, treated it like window, but it's not window, it's the dollar scope, so it's fine. Like it's not that global anymore, which is a bit weird. But we've since learned, like Redux kind of showed that pattern of having one place and controlling the mutations, like the kind of benefits you get from thinking in that way. And Reframe does kind of that. The atom is like a technicality. All it means, and in a browser it makes no sense because the browser is single-threaded. But like on a JVM where you are threaded, it's an atomic data structure that you can apply a change to, and everybody else who's at that moment reading it will block until the change has been applied, and then they can carry on getting the new values out. So if you've got 4 threads incrementing the number, it will actually plus by 4. You know, it won't end up at like 3 point something because, I don't know, the moon was in the wrong orbit. Like threads are hard, but that's a nice data structure. So this is what our fictional database would look like. It looks a lot like a Ruby hash. It's just not JSON syntax. It's starting with the colons, also keywords. There's no need for commas to separate the items. The Lisp interpreter just simply counts them in pairs and expects them to be in pairs. And once I saw this, I was like, wait a minute, like somebody needs to do this for Ruby because I don't know why we need the commas and the hashes. Subscriptions is a way to now get value from this one global data store. So your application or your views never really interact with the database directly. They just subscribe to data. They don't actually care where it's from. You can have subscriptions that point to WebSockets. And as data comes in, you can have data flow out. But we just want a piece of data. And essentially what that says, let me beam us in. That's the name of the subscription. And when you ask for a value, it will call this anonymous function. and it gets the value of the database, and you're just reading a value out of it. So it's basically that, if you were doing normal JavaScript, just going like db.counter. So it looks like a lot of ceremony to just get around to that, but these things can start building up. Very much like Excel, cells can start depending on other cells, and you can start to have very complicated values flow through your system. So this function now does not get the database anymore, it gets the output of counter, and you can stack many of these dependencies depending on what your system looks like. And that's the value that's returned, which essentially is the same as db.counter plus 1. This becomes really nice if you think of people having like big sorted lists in tables, and eventually want to render something that's just the sorted list. You just want the data, you don't care where it came from. In other places you can like control all the values and like sort your list by however you want it, and as far as your view is concerned, it doesn't care. It just gets a value. We need to update these values, otherwise it'll be pretty useless. And for these you register event handlers, and you get two kind of event handlers. I'm just showing the one that just simply mutates the state here. But you get other event handlers for exacting side effects. If you want to do H3P calls, so like reach out into the wild world where you've got no control, they're very easy to make. It's got a name, increment the count, and it gets, in this simple case, just the db value, but if you had more arguments to give it, you would just simply yank more arguments for this function. And this function, you give it a collection, it will pull the value out of the collection and pass it to that function, so you're just incrementing the value. And this value that gets returned from this function, worth pointing out, it's exactly the same like Ruby. The last piece of the function that evaluates, its return value just goes out, and its return value goes out, and its return value goes out. So no need to ever explicitly, actually we don't even have a return statement. So what gets returned by this is a whole new database, a whole new piece of state. So you can imagine if you get a bit smart with it, you can hold on to the before and put it somewhere, and there's the after, and you can make a little tool to just go like, what went wrong? I clicked the plus button, but the name disappeared. And here you can kind of figure out exactly like what the before and after in your world is, which is a really nice trick. And that's exactly what they built stuff for. So they've got this idea of interceptors. You can think of it as like rack middleware, but they intercept in an event chain that's getting handled, which is also pretty nice. And this example, that little reframe debug interceptor does exactly that. I've got a video showing some code, and you'll actually see like in the Chrome DevTools how it's doing the before, after, before, after, before, after. It is so useful when to see what's exactly going on. And then it's more like as a sideline. When you compile the code with the Google Clojure compiler, that value is false. The compiler is smart enough to figure out that this whole statement will never evaluate, so those lines never even make it into the compiled bundle. And I mean, this is a simple example, it's a debugging example. You can think you can pack your system with so much information and have it all in CI and running and test, and then for your final build, you just strip it all out. And that is quite a nice feature of it. Then you can hook that little interceptor. It's like an array of interceptors. It's just little square brackets in there. That's exactly what we had, but now suddenly we've got insight. We can see what our tools are doing, which is really quite pleasant. But let's actually make something useful. So let's show that count value on the screen. So that's subscribing to the counter. This is not the exact value. You can just call it like a little magic container. It's almost like a promise that the value will be there eventually. And when you render it out on the screen, this looks a lot like HAML, except using nested arrays to define your HTML structure, which is actually quite nice when you start treating your HTML like data. It also becomes like an interesting thing that you can massage HTML going in and out of functions. It's a really nice way to work, actually. It takes a bit to get your head around that part, or for me at least it did. And then that magic at incantation there is basically when the values here show the value. Whenever the output of that subscription changes, this whole piece will get re-rendered. So you don't even need to do anything. This is where the React magic and stuff comes in. And the benefit of using ClojureScript that can detect if values have changed or not, these integrations into React are like, they actually get a bit invasive, but they prevent React from doing a bunch of stuff that it would normally do, even when no values have changed. So we actually get performance characteristics that's faster than React doing it themselves, just because we've got persistent immutable data structures, which is pretty cool. And then like any React app, you just build up bigger and bigger ones. This one's rendering out the name, and that's our little nested component. And if name changes, the whole block gets re-rendered, otherwise counter will just get re-rendered in this place, like pretty standard React stuff. If you want to, sorry about that. If you want to have side effects in the world, somebody clicks a button, what are you going to do? That's a little anonymous function, and this is pretty much what we're used to doing in JavaScript in any case. You know, on click and immediately just define an anonymous function and handle the event there. Here we just have the luxury of just giving it like a small name for now. We don't need an on click somewhere else. It just needs to exist here, and it will dispatch that event that updates the database, and you're going to start seeing the loop completing itself. So side effects is a nasty thing in any kind of situation, in front end specifically, because actually almost everything you do there is the side effect of side effects. It's really complicated state, especially in our world. We used to like request response cycles, which is nice and clean, but these things build up so much cruft while you're running, it's absolutely insane. So we need a really good way to handle them, affect the world in a very, very consistent manner, in a predictable manner, and to move it all forward. And that's kind of where those interceptors come in very interesting ways. Like when everything becomes so predictable, things become so much simpler, and you can start focusing on what's done for you. And then finally on the DOM side, there's nothing for us to do. We produce these nested arrays, and there's other libraries in between that will turn this for us into something that React can use to render a DOM, which is nice and fast. And that's a complete example with everything stitched together. Dispatching these events and keeping track of stuff it is really important. So I just chose routing as a simple example, but this is kind of the pattern you start thinking of over and over and over again, is you dispatch events with some value. Now I'm not going to show, I don't have the code on the slides for this, but again, all this does is again just updates that DB to go, this is what the user is actually looking at. And then from the very top of the DOM all the way down, the effects render out, pretty much the same way we do in a React app. And you'll dispatch different things. So we had examples of blogs earlier, and so you can just dispatch multiple events. The one is to go and load the blog post. So that one you can imagine would have a side effect. It is now going out to the world to talk. And then there you would handle like, there's a loading state to show the person we're busy, fetch the data, handle a success or a failure, give them all kinds of feedback. But it's just these simple little steps that like very, very reusable. Hard to name, but very, very reusable. Oh, video. So, yeah, it doesn't sound like much until you play with it. And we've just scratched the surface. Out of the box, you get a browser-based REPL. You get hot code reloading that works. And I don't mean that like tongue-in-cheek. It is amazing how well it works. And Rails always used to use live reload. They would just like hit the refresh button for you whenever you've changed things to speed it up. Because of the immutable nature of the language, or at least the way we perceive it, I mean the software works a bit differently. As you're changing code, those new functions can just be recompiled into JavaScript, and the existing ones get replaced in the DOM and they get re-executed. So you have an amazingly fast feedback loop as you're working. Everything's just updated. And you can interact with the running system in the browser, which is a very unique Clojure thing, that where you're working and where your system's running can merge. It's so much fun. It's better than IRB. Like Rails console is fantastic, and that makes such a difference, especially in prod if you need to go quickly poke out with something and see what's going on. This is a whole different world of REPLs, and I think it's like a Lisp advantage. Other languages can't really implement it this way. But you get source maps with syntax highlighting. Chrome DevTools supports ClojureScript out the box. Ironically, so some people they just are a bit geeky and they really love it. It's compatible with all the React dev tooling if you're using that already, which is quite nice. And like I mentioned earlier, the interrupt story is absolutely fantastic. You've got access to all the other work that other people have done to make your life easier. Oh, get him on. So it's demo time. But unlike all these other people that can do live demos, live coding, not me, not taking the chance. I love that that's supposed to be the precursor to Murphy's Law. The first experiment already illustrates the truth of the theory, well confirmed by practice. Whatever can happen will happen if we make the trials enough. So that's quite a good one. All right, so I'll play the video now. I just want to point out for you what to look at. Unfortunately, this piece I never zoomed in properly when I recorded it, but it's more that you'll see how much activity is rather than what the activity is. This is the little sample. There's the hello name piece that we had, and there's our little counter and the increment. This side is the actual code where you'll see me edit it, and then I'm going to click that button to get a little debug panel that pops up that allows you to see into the state of the system. Right, so that's refresh getting popped out. So there you can kind of see the values of the world at the moment. As I click it, yes, debug before and after, 0, 1, 1, 2, 2, 3. Up there you'll see the values, update live. The history of events. So you can kind of inspect exactly what was in your payload, which is useful if you've got events coming in from outside, like an AJAX response. And now on this side, I want to add to reset the count. So I'm adding a little event handler that all it will do is just set the count back to 0. Right, so that's what that one does. Now, I want to know if it works. So now, this is the REPL, and it's connected to the browser. I can dispatch this event here, and the value did reset. The page didn't even reload. You can see from my history here, like everything is still going. And now I'm triggering the commands, the other events, in an editor, and it's triggering off everything in the browser. And then, well, the only next thing I do is I add the button with the on-click to trigger that. Oh, no. So basically, making the new anonymous function, which we'll call reset. Adding a bit of markup to get it into the dev. So as I save the file, immediately the button was available. It just re-rendered the component, which is quite nice. Okay, I believe that's the end of that one. Sorry. The tooling is really good at giving you feedback, but it's like probably the best thing of working with a real REPL. I didn't know what that meant until I played with it a bit. But you get nice warnings. It tells you what's going on that you can work with and figure out. If you completely butchered it by forgetting one of the 1 million parentheses, it will actually show you a red banner and go like something's wrong here, which is quite useful. I mentioned you get the source maps for free, so that's in the Chrome DevTools, and you're seeing the ClojureScript code. You don't need to, like in CoffeeScript days, have to go and like reverse engineer the JavaScript back to what you wrote. So this is a really, really nice way to work. And the React DevTools, it's really easy to see where the components are, and you can fiddle with the state and see what's up. And this is kind of always a question if you like change tools or consider something. Come on, screen. So Clojure offers a lot of facilities to keep things sane. I mean, I had these short names for things like it's a counter, and reset count, and int count. In reality is you can't work like that in a big system. Things get muddled up. So you can use namespaces to separate stuff that would otherwise be exactly the same, which is a pleasure to work with. You can have as many namespaces as you need. The event IDs, description IDs, everywhere where there's a keyword, you can have namespaces to disambiguate it. the tooling can run for days at a time, which is really interesting to see. Like, it simply doesn't fall over. They've done an extraordinary amount of work to make sure there's not real memory leaks or big problems for you. It all just works fine. And it's that everything's just data. That's all your markups data, the state of the world's data, the changes you apply to it's described in data. It's a really nice way to work. I can harp on about the interop story as well, but it's so refreshing. We can just go and find a good JavaScript library and plug it in and carry on. Things generally work like that. You can use all the existing React components. So if you want to use like semantic UI React, you can just pull it in and start using it. It might take a bit of a dance the first time just to get the interop story right, but you hide it behind a nice function and you're off to the races. And the NPM integration is getting really good. Really, really good. These guys are working with the Google Clojure compiler to just make the whole ecosystem better. And there's a bunch of other benefits going out to the rest of the JavaScript community as well, which I'm excited about. And that's part of that advanced code compilation. Like, stuff is absolutely crazy how that thing can just get rid of dead paths, inline numbers. So yeah, if you do that XKCD random number, it returns 4 as determined by a dice roll. You know that it will like rewrite your function to just be a value that returns a number. A ton of amazing stuff. And you can also do code splitting, which is also quite nice if you want to have like your admin bundle separate to your main app bundle, separate to all your vendor dependencies. Pretty standard stuff around that. Who here has any exposure to Clojure in any way? Okay, a few hands. Because this is a bit more, this is a very new thing in Clojure. I'm not going to harp on it too much, but it's really interesting in the sense that I think it's Clojure's idea or attempt to build a type system that's not a type system. It's about defining constraints over your data, and it's about defining open constraints. So we can put in anything in our DB, anything we want. It doesn't matter. The data structures are open for extension. But if you put an ID in there, a count in there, it must be an integer. And if you're putting a name in it must be a string. And you can build it up with these predicate functions, but you can also turn it around and then generate values. You can have generative tests that can understand your data structures, which is quite a nice thing to work with. Starting to use this more and more in production, it's absolutely great. And it just builds up into a little bit of tooling. I really don't want to spend too much time on it, but we mentioned the interceptor, so you can build an interceptor that you can plug in with your debug interceptors. So now while you're busy building your app, and you just, like, I mean, you're working at a fast pace, and you just screwed something up, immediately you get some useful feedback. And in production, you can hook this up to Sentry or Rollbar, Bugsnag, whatever, and then same thing, catch an error with a super clear explanation of what's going on. There's some other tools that I didn't want to show so much because that, like, you need to have bought into this a bit for these things to show, but this amazing way with refrisk was that little window that I popped out. You can do point-in-time debugging, so you can literally go back in time. You're like, okay, what happened here? And then just start playing forward again. And there's some other great tools that's also out that allows you to do exactly the same thing. So if you want to go, which I hope someone would want to go, is that you can go look at the README of this fantastic library. I think the README has, or the documentation is more than the source code. It's absolutely insane. And yeah, that's me.